Hi everyone! Today we're going to be talking about evaluating functions. Our objectives for today are that students will be able to write functions in function notation and evaluate functions. Let's get started. Alright, so function notation. When we're talking about function notation, what we're doing is we're saying that equations that represent functions, we write them in function notation. So for example, if we have the equation y equals 2x plus 7, if we wanted to write that in function notation, we would write it as f of x. So if it looks like this, we read that as f of x equals 2x plus 7. All right, where x is our input and f of x is the output. So the whole idea of a function is that you have an input, you're putting in a value, and you should get something out of it. So think of a function like a machine. We're putting our x value in, and our f of x should come out, or our value. Like, think of it, an analogy would be like a cow. We put the cow in the function machine, and we get a steak. Sorry for those of you who are vegans and vegetarians. This analogy is probably not the best for you, but that's how I want you to think of a function. We put something in and we get something out. Input our x, f of x comes out. So when we're evaluating functions, we use function notation because function notation is specifically useful for finding a value in the range that corresponds to a certain domain value. So for example, if we have this function right here, so if f of x equals 2x plus 7, we want to find f of negative 3. So our x value, our input, what we're putting in the function machine is negative 3. So what this means is every time we see an x in our function, we're going to substitute in a negative 3. So how we would write this is we would say that f of negative 3 equals 2 times, and whenever we see an x, we're going to substitute our x value. We're plugging in what we're looking for, all right, our input, plus 7. Then it's just solving. So 2 times negative 3 gives us negative 6. Negative 6 plus 7 gives us 1. So f of negative 3 equals 1. So we put x in, we put negative 3 in our machine, plugged it into our function, and we got 1 out of it. All right, so 1 is our output. So f of negative 3 equals 1, and we just evaluated that function. All right, so for the next few example problems, we're going to be using these two functions. So we're going to use for f of x, we're going to use negative 5x minus 14, and for g of x, we're going to use negative x squared plus 9x minus 1. All right, so the first thing you want to do is identify which function you're using. So number 1 is asking us to find f of negative n. So we're going to be using our f of x function. So what we're going to do is we're going to use this 5x minus 14, and every time we see an x value, we're going to substitute in negative 9. So f of negative 9 equals negative 5 times our x value that we're putting in negative 9 minus 14. Now it's just solving. Negative 5 times negative 9 gives us 45 minus 14. So f of negative 9 equals 31. And you're done. So number 3, we're looking for g of 0.4. So since we're using, it says g of, we're going to use our g function. So what we're going to do is plug in 0.4 every time we see an x into this function. So g of 0.4 equals negative, and we plug it in using parentheses always, especially when we've got those exponents and negative signs, squared plus 9 times 0.4 minus 1. Now we're just solving the equation. We want to do order of operations, so exponents come first. So we would want to take 0.4 squared first. So that's going to give us negative 0.16 plus 9 times 0.4 minus 1. Next thing you want to do is multiplication. So we bring the negative sign. We're multiplying it by negative 1 essentially. All right, plus 9 times 0.4 is going to give us 3.6 minus 1. All right, so this whole thing equals negative 0.16 plus 3.6 minus 1. All right, I don't know why I just rewrote that, but I wanted you to see it a little bit more clearly. All right, now we're going to do order of operations. So, order of operations tells us we've got addition and subtraction. We're going from left to right. So we're going to first do negative 0.16 plus 3.6, and that's going to give us 3.44. Then we're subtracting 1. So our final answer is 2.44. So G of 0.4 equals 2.44, and that would be our final answer. All right, number 5, we have essentially a compound function that we're evaluating because we have two functions that we're subtracting from each other. So there's two different ways you can do this. You can first find f of 1, then find f of negative 4, then subtract your answers, or you can just write them together all in one line. All right, so I'm going to show you both ways. First, if we do it all together, all right, so writing it all together in one line, what we're doing, we know we're using our f function, and our first function is going to be f of 1. So every time we see an x, we're going to plug in 1. And then we know we're subtracting f of negative 4. So we would say negative 5, we plug in a negative 4 every time, minus 14. Now order of operations, solve what's inside the brackets first. So we get negative 5 minus 14 minus 20 minus 14. So we have negative 19 minus 6, which gives us negative 25 as our final answer. All right, so negative 25 is our solution. Now, if we wanted to do it the other way, all right, so both of these ways are correct in doing it. You can do it one of two ways. This is the first way. All right, this is the way I actually prefer just because it's a little less writing. All right, but if this is confusing to you, here's another way you can do it. All right, what you can do is you can first solve for f of 1. So f of 1, we plug it in. We say negative 5, plug in a 1 every time we see an x. We get negative 5 minus 14 gives us negative 19. All right, so negative 19 is equal to f of 1. Then we would solve for f of negative 4. So f of negative 4. Every time we see an x, we plug in a negative 4. So negative 5 times negative 4 minus 14. So negative 5 times negative 4 gives us positive 20 minus 14 equals 6. Then you would take each of these solutions because we know we want f of 1 minus f of negative 4. So f of 1 equals 19, negative 19. All right, this equals 6. So now we just subtract our two answers. So now we're saying negative 19 minus 6. And then that equals 25. All right, so both ways are correct. Whichever way you prefer, you can do. All right, and we're going to do number 6 together because now we're multiplying. I wanted to be sure to do one of these examples with you as well. All right, so we're doing it even. So number 6, we're saying we're going to do 2 times g of 12. So we're using our g function. So we want to say 2 times, and then using our g function, we're plugging in a 12 every time we see an x. So we've got negative 12 squared plus 9 times 12 minus 1. So it's 2 times, we solve what's inside the brackets first. Negative 144 because we squared 12 and then added the negative, plus 108 minus 1. All right. Now negative 144 plus 108 is going to give us 2 times negative 36 minus 1. 2 times negative 37. 2 times negative 37 is going to give us negative 74. So negative 74 is our answer. You could have just solved for g of 12 and then multiplied your final answer by 2. All right, it's essentially the same process. All right, number 7 It's the same idea, but now we've got two different functions. We've got p of x and q of x. And for number 7, we've got a fraction, so don't let those fractions scare you, all right? So number 7, we're saying p of negative 9/16. So we're going to be using our p function, and we're going to plug in negative 9/16 every time we see an x. So we've got 1/2 minus 4/3, and we've got an x, so we're going to plug in negative 9/16. All right, now before multiplying our fractions together, let's cross-simplify to make life a little easier. So we can divide the 3 and the 9 both by 3. We get 3 on top, 1 over here. 4 and 16, we can divide both of those by 4, so we've got 1 and 4. And then essentially we can rewrite this as 1/2 minus 1 over 1 times negative 3 over 4. All right, now negative 1 over 1 times negative 3 over 4 is going to give us plus 3/4. So we've got 1/2 plus 3/4. We're adding fractions, so we need common denominators. So we're going to change 1/2 to 2/4 plus 3/4. Add our numerators together. And oh, why did I write a 7? This is a 4. All right, now 2 plus 3 gives us 5. 5 over 4. So 5/4 is our final answer. P of negative 9/16 equals 5/4. All right, I want you guys to try number 9 on your own. All right, remember to first identify which function you're using and then plug that value in. All right, when you come back, I'll have the answer written on your screen and we will go through it together. So go ahead and pause your video now. All right, you should have gotten 2 as your final answer. So we first identify we're using the q function, so we're plugging it into this function right here. So every time we see an x, we're going to plug in a negative 2, and we want to be sure to use parentheses because it matters, especially when we're cubing. All right, so then order of operation tells us that within the absolute value bars, next we want to do exponents, so we want to do negative 2 cubed, or to the 3rd power. All right, so negative 2 times negative 2 gives you positive 4, times negative 2 gives you negative 8. Next, we want to multiply 3 times negative 2, we get negative 6. And then when we're subtracting a negative number, same thing as adding the positive value. So negative 6 plus 8 gives us 2. Absolute value of positive 2 is positive 2. All right, if you have any questions, remember to call me over, raise your hand so I can help you. Otherwise, let's move on. All right, so number 11 is the same idea as what we did in number 9, all right, but we're going to take whatever we get for q of 4.5, we're going to say 7 minus that value. All right, so same idea. We want to say 7 minus, and we're going to use our q function and plug 4.5 in. So we use a bracket to help us remember that we want to solve it first before doing 7 minus that value. All right, so absolute value of 3 times 4.5 minus 4.5 to the 3rd power, and the absolute value of that. All right, so those brackets remind us we've got to solve what's inside them first. So the absolute value of 3 times 4.5 minus, all right, because we want to do 4.5 to the 3rd power first because order of operations tells us exponents first. 4.5 to the 3rd power gives us 91.125. All right, and we're going to want the absolute value of this. Then we're going to multiply 3 times 4.5, and that's going to give us, let's see, 3 times 1.5 gives us, or times 4.5 gives us 13.5 minus 91.125. Now, absolute value 13.5 minus 91.125 is going to give us, let's see, negative 77.625. Then we need some more space here. All right, then the absolute value of negative 77.625 is just positive. Actually, we don't even need the parentheses, right? Because we're saying the absolute value of this gives us positive 77.625. All right, now we're saying 7 minus 77.625 gives us our final answer, and our final answer is going to be negative 70.625. And that's our final answer. All right, so number 13 is a little different. All right, we're using this f of x function, this f function, all right, but we're given that f of x equals a certain value, and we want to find x. So essentially it's the opposite. Normally we're given x, and we want to know what does f of x equal. So in order to do this, what we're going to say is we're going to substitute this value. We know f of x equals 34. We're going to substitute that in for f of x. So we want to rewrite this as 34 equals 3x plus 19. Now we're just solving for x. So we want to move the numbers to one side, so subtract 19. 34 minus 19 gives us 15. Divide by 3. So x equals 5. And that's it. All right, number 15, we've got a word problem. So Owen paid a landscaping company $108 for an initial lawn treatment and then $74 per month thereafter. So they give us a function. The function p of t equals 108 plus 74t represents the total amount of money he will have paid after t months. So t represents the number of months. The first part is asking us to find p of 24. Then what does this represent? So first let's find p of 24. So p of 24, what we want to do is we want to say p of 24 equals 108 plus 74, and anytime we see t, we're going to plug in 24. All right? So t is essentially just our x, our input. Now we're just solving. So 108 plus 74 times 24 is going to give us 1,776. Then we add them together and we get 1,884. So what does this represent? What this is saying is that it's going to cost us $1,884 is the total he's going to pay for 24 months of lawn service. All right? So this includes, this is the total paid for the initial treatment and 24 months of service. So that's what this number represents. How long has Owen been receiving lawn service if he has paid a total of $2,994 to date? So now the second part of this question is asking if this is our P of T, this is our output, right? This is what it equaled at the end. This was our total. So we want to take this number and plug it in to here. So we would write an equation that looks like this. We would say 2,994 equals 108 plus 74t. Now we're solving for t. So how long? We want to know how many months we're solving for t. So start by subtracting 108. These will cancel out, and we're left with 2886 equals 74t. Divide by 74. 2,886 divided by 74 gives us 39. So if he has paid a total of $2,994, he has been receiving lawn service for 39 months. Alright, so last couple of examples are slightly different because now our input has a variable in it, alright? So our input, or our x, has a variable in it. Our input here, we're using the f of x function, but our x, or our input, is 7w minus 5. We're going to treat it the same way we did when x, or our input, was just a number. So we're going to use this equation, and then we're going to write it out. We're going to say -4, but every time we see an x, we are going to plug in 7w minus 5. So 4 times our input, our x, plus 9. Now we can't solve this, but we want to simplify it. So start by distributing the -4 to both terms. So we get -28w plus 20 plus 9, -28w plus 29. All right, and that is our final answer. All right, our final answer is not going to be a number, all right? It's just going to be a simplified expression. All right, and last but not least, number 19. All right, normally I would make this a you try problem, but because this one's a little bit trickier and I don't want you guys to get discouraged, I want to do this one with you. All right, so you know, don't form any bad habits with these. Okay, so number 19, we're saying g of a minus 3. So our input is an expression. We've got a variable in there. So we're going to use our g of x function, and every time we see an x, we're going to plug in parentheses a minus 3. So we say it equals x, so we plug in a minus 3 every time we see an x, and then squared minus 5. Now, a minus 3 squared, we cannot just distribute the 2 to the a, the 2 to the -3. All right, that is a common mistake that I see all the time. Do not do this, all right? A minus 3 squared, the easiest way to remember what to do is to rewrite it. So what this means is it's a minus 3 times a minus 3. And then it's minus 5 at the end, all right? We can't forget about the 5. So we can't just essentially distribute the square, all right? That doesn't exist. We don't do that. What we have to do is FOIL this out, all right? So hopefully you guys remember FOIL, all right? We multiply the first terms together, the outer terms together, the inside terms together, and the last terms together. So we say a times a is going to give us a squared. The outer terms, a times -3, minus 3a. The inner terms, minus 3a. The last two terms, -3 times -3 gives us positive 9. And then don't forget about that -5 at the end, or minus 5 at the end. Now we're just combining like terms. So we've got -3a, -3a. That gives you -6a. Got a squared in the front. And then we can combine the like terms of 9 minus 5, all right? That's going to give us 4, so plus 4. Now this is our final answer, all right? So you have to remember to FOIL. Don't just distribute the squared, all right? That's not a real thing. FOIL it out. All right, last but not least, we're going to do a real-world application problem, all right? AKA word problem. So number 21, swine flu is attacking Porkopolis. The function below determines how many people have swine, where T stands for time in days and S stands for the number of people in thousands. All right, so this is our function right here. S of T equals 9T minus 4. Part A is asking us to find S of 4. So we want to know what is the number of people in thousands when time in days is 4, when T is 4. So we would say S of 4 equals 9, and every time we see a T, we want to plug in 4, minus 4. All right, so when we're evaluating functions, we plug that number in for our variable. So we get 36 minus 4 equals 32, and this is 1,000 people. All right, so 32,000 people is our answer there. Now, what does S of 4 mean? So S of 4, what that stands for is the number of people in thousands. All right, because that's what S stands for, the number of people in thousands that have swine flu after 4 days. All right, so we know that 32,000 people have swine flu in Porkopolis after 4 days. Now, part C is asking us to find T when S of T is 23. So what this is saying is when the number of people in thousands is 23, so when there's 23,000 people who have swine flu, what is T? How many days did it take for 23,000 people to get swine flu? So if our function is S of T equals 9T minus 4, what we want to do is we want to substitute in 23 for S of T. So 23 equals 9T minus 4. And now we're just solving for T. So add 4 to both sides. We get that 27 equals 9T. Divide by 9. So T equals 3. So after 3 days, 23,000 people have swine flu in Porkopolis. So now we want to put into words, what does S of T equals 23 mean? It means the number of days, which we just found was 3 days, when the number of people with swine flu is 23,000. Now, part E. I wrote challenge under part E because we haven't necessarily learned how to graph S of T equals 9T minus 4. But if you remember slope-intercept form from Algebra 1, hint, hint, we're going to learn that this chapter in a few lessons. Actually, I think next lesson we're going to talk about slope-intercept form. All right, it looks something like this. All right, so if you can remember how to graph it using that, kudos to you. You've just beat the challenge. All right, if you can't remember how to do that, then when in doubt, if you're trying to graph a function, make an XY table. So that's how we're going to graph it together right now, is using an XY table. So we want to graph the function when x is 1. If we were to plug 1 in for x, or in this case, t is our x, right? And S of T is our y. So if we were to plug 1 in for T, 1 times 9 is 9, minus 4 gives us 5. Plug in 2 for T, 18 minus 4 gives us 14. Plug in 3 for T, 27 minus 4 gives us 23. Plug in 4 for T, 36 minus 4 gives us 32. And then we would just want to take these points and plot them on our graph. All right, and I'm going to erase this up here just so we can use our graph, okay? So we want to label our axes. All right, so our t, or our x, is time in days, right? And then our y-axis is our people in thousands. And then we want to label our axes. So let's say that every 2 boxes is 1 day. So 3 days, 4 days, 5 days. And then we want number of people in thousands. So let's go by, like, I don't know, how about by 2s? So 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32, 34, 36, 38, 40. All right, so we always have to label our axes, especially if we're not going in intervals of 1, okay? So our first point is 1, 5. So when the number of days is 1, 5 people had swine flu. Put it up. Our second point, when 2 people, after 2 days, 14 people had swine flu. So 2, 14. Put it up. 3, 23. So after 3 days, 23 people had swine flu. 4, after 4 days, 32 people had swine flu. All right, and that gives us enough points to connect our dot and get a graph. Connect our dots and get a graph. So let me get a line here. Let's see if I can draw a line. All right. trying to draw a line, but it's not really working out here. I'll just draw it. It'll be a little shaky. I apologize. All right. There's our line. You would want to use a ruler. All right, so it's a nice straight line. And there's our graph. All right, so there's our real-world application. When we're talking about evaluating functions, we're dealing with swine flu and porkopolis. Hope you learned a thing or two about evaluating functions today. If you have any questions, feel free to ask. Otherwise, look to the board to see what to do next, and I hope that you have a great day.